Hi, this is Tag again, and today I got a DFI board here. Now this is one of the 790FX DFI Lanparties that I talked about a bit in the Athlon benching video. This one is not the one from the video, but this one is the first one that I tried. Now this board works, but this is pretty unstable, and well, I think here is the reason for that. We have a burnt up high side fat on the main V-core VRM. I suspect this has to do with the VRM being absolute garbage and only a 4-phase. And the previous owner of this board using a Phenom II X4 CPU on here. When I bought this, it came with a Phenom II X4 940. And well, it was sold as broken, which was sort of half right. Again, this board posts and boots into Windows, but it is in no way stable. So basically what I wanted to do today is just replace this fat and well, see if it improves our situation here. So let's set this up. Add some aluminum foil around the area. I need more. Just hopefully just remove it without leaving anything on the PCB. I just hope it didn't like burn a hole in the PCB itself. Okay, so let's get some tweezers, heat gun, and, well, not heat gun, hot air station, and see what happens. Maybe add some flux. Not sure which direction is the best to use here, honestly. I think downwards. But then again, I expect this to be quite hard to get off because it might have welded itself to the PCB. They tend to do that when they burn up. Okay, our low side is melting, our high side isn't. This is not a good sign. I fear this thing has welded itself on here. Wiggle it a bit. This one is already just Yeah. Yep, this is going to be a bit of a challenge. I mean, it might in theory be possible. Let's see. Remove this foil here, and there we have the fat. And it completely lifted up the copper layer of the PCB. Can you see this? Here is copper. It's completely mangled. The gate seems fine. But the other two pads are pretty damn destroyed. So let's get a multimeter. Now I don't think this board is lost or anything, but it will be a bit more challenging to rebuild this. So this should be connected to here. It's shorts on. Great, you can't see the multimeter, obviously. There we go. So we have no shorts on 12 volts. No shorts on V-core. And this should be connected. Yes. Okay. I can work with that. Now these fats are pretty toasted, but we have double overkill low sides on here, so I'm not really worried about the fat being toasted. Shouldn't really matter. Just good that we have this pad here. This would be 12 volts. So we have to be careful that it doesn't touch anything. And what does this resistor between they do? Okay, so this side is okay. This is 6.5 kilo ohms. Where is it here? I saw it here under the garbage. Interesting. Okay. 10 here. 6 here. This is odd. Is one of our faces up here also dead in some way? But it is 10 here, yes. This is 2 ohms. This is also 2 ohms. Is this one? I feel like our fat here on the second phase is also dead. This side hooked up to anything else? Is it the same the other way around? I'm starting to suspect this fat of also being shorted, but I'm not 100% on that. This side is the gate. Yes. So this resistor is between, what is this? Gate and source. I think. Should be 10K on all the other ones. Okay, this is just a capacitor that is not in the same circuit. For now, let's just throw a bunch of contacts at the problem and see what we, or isopropanool, see what we got left for pads. The upper one is obviously destroyed. I don't think the lower one is salvageable either. No, I don't think so. Now the main question is just if we replace the upper phase MOSFET as well. Which I would think is a good idea. Just going to leave that one for now. Just try to put back a FET on here and see what happens, I guess. It's pretty messed up, this PCB. Anyways, let's get us a FET. Zoom out. This is some sort of donor board. This one right besides the memory slot is the right one. I don't care about like toasting the plastic or anything on here. This is just a random Dell OEM board. Okay, no hot air directly on the FET after it's removed. And the Dell board is done. Now I won't be using hot air, I think, to put this FET back. I think I will just be soldering it with the normal soldering iron. Push it down, solder it on there. I think that's the best bet. Before that wick the gate a bit. Okay. Gate is wicked. Now let's just hope I can. This camera is focused way too far up the bench. Yeah, that should work. Yeah, that will work. Okay. That should stick. To the gate. And this bottom pad here. Gate works. This pin here is a bit of a problem. It sticks here, but I don't trust this tiny little burnt sliver of copper to actually work with the voltages, with the current we are having on a VRM like this. So I'm going to do a bit of improvisation. To solder a tiny bit of copper plate right between. Also tune this because I'm not sure if it's connected. Camera is annoying. Okay, it's more flux. Now obviously when putting my little piece of copper plate on here, I have to be really careful that it doesn't stand out too far. Because ultimately we are going to be putting a heatsink on here. Chipped away. Okay, that should handle the current, no problem. Height is okay. Now let's just get a 10K resistor. Put it in there, sort of crooked. Okay, I think I got it. Sorry if you don't see it, but I have to sort of work on a piece of the bench where I can actually see it, which is unfortunately not the piece of the bench where the camera is focused right now. So I might have set it up a bit wrong. Okay, so there we have our resistor. We have a bit of a knob here, it's not good. The heatsink, okay. The smaller soldering iron. You could see how far up is this? Way better. Way better. Okay, let's measure. No short, no short. 6.4K. Maybe the bottom phases just are supposed to be 6.4K or our VRM controller is short. In which case there is not really much we can do. But our fats are all fine now. Yes. So I would almost dare to turn this on and sort of see what happens. Now I just have to find a way to cool the chipset on here that does not involve putting on the entire heatsink. Also by the looks of it, there was a jumper here that I either melted off or ripped off with the aluminum foil. I have to replace that as well. Anyways, I will now sort of move this over at the bench and hope for the best. Obviously clean it before that, and well, be right back, I guess. Okay, here we are. I put a copper slug on the north bridge, little cooler on the CPU. This is a reject 6000 plus, so it doesn't matter if it blows up. So let's turn it on and watch the fireworks, I guess. Hopefully not though. Don't see any smoke, but I don't see any postcode either. Turn it off. Postcode is stuck on 00. Or this board's version of 00 at least. So why is that? Something is getting warm, but it is not. Actually, maybe this jumper that we had on here is required for usage. Let's replace that. Okay, put a jumper on there, let's see. That's absolutely nothing. I can't measure voltage with one hand, so have to just measure it and be back afterwards. Okay, so I don't know what changed or what happened. I measured voltages, we have V-core. I also measured the gates on all the high sides. And well, that's always something you should do. Basically to find out if the MOSFETs are driven at all. They should all be roughly the same. And in this case they are 2.5 volts, which is, I would say, quite alright. That's a duty cycle of like less than 25%. So seems alright. Board now posts and goes into BIOS. I looked at, yes, while I was diagnosing this thing, apparently the battery of the thermal camera ran out or it turned itself off or something. Anyways, I looked at the VRM area and all the fats get equally hot or not hot. So they stay pretty cool. So I think this thing is fixed, at least for now. It still behaves weird. Let's press the reset button and see if it posts again. Yeah, of course, now it works perfectly. Turn it off. Turn it on. C1. Post. I have no idea what went wrong here. It wasn't a jumper because it didn't post with the jumper on first time anyways. So let's have a look at this. This is terrible with camera and thermal camera. But I think you might be able to make out the banks of fats here. And the thing that gets warm is
well, all of the feds, and this is, I think, a quad driver in one deal. The thing between the caps. This gets a bit hotter, as you can see, like 55 degrees. But nothing to worry about. None of the feds get abnormally hot. The controller is a bit warm, but it also doesn't matter. There is one fed down here, but that is not part of the main VCore VRM. So yeah, I really wish I had a phone camera that was like on your phone, so I could make proper videos and not like hold the camera in front of another camera. Anyways, VRM looks like it's working fine now, and well, I'm obviously going to understress the board, as in I will put a sticker on here that says like only use dual cores, basically. Though I think DFI should have put that sticker on there from the factory, because these boards are not cut out for quad cores. If you want to run quad cores or even 6 cores on a DDR2 790FX board, run them on the Gigabyte, please. Gigabyte actually made a decent VRM. Now, you know I don't like their BIOSes, but their electrical engineering is actually pretty solid usually, surprisingly enough. But then again, maybe not that surprising, because those are very likely 2 different teams. Yeah, turns on right away. So the board seems happy now. I would say success. We'll just, well, obviously get some new thermal pads for the feds here, because the original one, actually I have it right here, let me show you. There's a massive burn mark on here, so that thing is no good anymore. Replace this and put back the original heatsink, which I think is a terrible construction with these tiny little nuts down here and this 2-part North Bridge heatsink. It has a top and a bottom that has the heat pipe. It's honestly pretty crap. This was, you'd really notice that DFI at the point of 790FX weren't really all there anymore. Anyways, I hope you enjoyed me fixing this little LAN party here. And yeah, that's it. Bye.